In Creo Parametric, you can use the Behavioral Modeling Extension, or BMX, in order to create a datum analysis feature that performs a calculation via a relation. Let's take a look at a scenario in which we would want to do that. Here I have a part model of a fuel tank. Let me go to the sections in my footer and activate my cross section. You can see that it has an irregular shape on the interior, so we can't just use regular geometry in order to calculate how much fuel is at a certain level. And that's what we want to do. We want to know at different heights in the tank what is the amount of fuel in here. If you take a look at the last feature in the model tree, it is a shell feature. I can go to Edit Dimensions, and I can see that this has a thickness of 5. And since the shell feature is the last feature in the model tree, if I calculate the amount of volume before the shell feature and after the shell feature, I'll be able to know how much of the volume is air. If I grab my insert here arrow and drag it, oops, let me make sure I'm just going to insert here. I don't know why I couldn't drag it. Here I have the shell feature now suppressed, and so you can see that here we have it as a solid. So in order to create a datum plane that represents the height inside the fuel tank, I'm going to create a couple of datum planes. Let me turn on my datum plane display. Oh, it's already turned on. Let me create a plane offset from the bottom here. I'll choose plane from the mini toolbar. Let me make sure that it's going in the right direction. And again, when I took a look at the shell feature, I saw that it was a height of 5. So I'm going to make sure that this is a value of 5. Let's go to the Properties tab and rename this to bottom, just so I know exactly what it represents. And now I will click the OK button. With that datum plane still selected, let me hold down the right mouse button so I can get to my mini toolbar to create another plane. I'm just going to drag it up some distance here. And let's go to the Properties tab and call this one the height. And now I will click the OK button. And I really only want to see the second plane. Let me hide the plane called bottom. So now let's perform a measurement. Let's go to the Analysis tab, and I'll go to the Measure dropdown. I'm going to measure the volume in the part. And when you perform a volume measurement, you have the option of selecting a plane in order to measure the one-sided volume. And here we can see the value. It is a big number. And now let's go to the Feature tab. Here it's going to create a parameter that's called one-sided volume. I'm going to use a much simpler name. I'm just going to type in VOL. And now I can use the Save button in order to make this as a feature. I'm going to give this a very simple name. I'm going to call this pre, as in before the shell. So that's good. Let's click the Close button. And so now I have the datum analysis feature created. For stuff I'm going to do later, I'm going to add a couple of columns to the model tree. Let's go to the settings and then tree columns. And for the first one, I'm going to grab the feature ID number. The reason for that will become obvious later on. And let me also go to the type drop-down list and change to feature params. I'm going to type in that name, VOL. And let's add that column. Let's click the OK button. And so now we can see the feature ID numbers, and here we can see the actual calculated volume in cubic millimeters. And now let's exit out of insert mode. Let me see if I can just grab the green bar. Yep, you can usually drag it up and down. I don't know why I couldn't drag it before. But now let's perform the same one-sided volume measurement. Let's go to the Measure dropdown and choose Volume. And once again, I will activate the plane collector and select the plane. And we're measuring on the bottom side of the part. Let's go to the Feature tab and rename this to use the same name, VOL. Let's go to the icon for creating this as a feature. I'm going to call this Post, as in after the shell feature. and close this. And so now you can see this is the volume before the shell feature. This is the volume after the shell feature. If I subtract the post volume from the pre-volume, that will tell me how much inside of here is air, or how much is the amount of fuel that will be below that particular datum plane. So let's now create a datum analysis feature that performs that calculation. I'll click on the analysis icon, and that opens up this dialog box. And there are 8 different kinds of datum analysis features that we can create from here. In other videos, I showed how to do a user-defined analysis and Excel analysis. We also have an external analysis, ergonomics analysis. There's MathCAD for the current version prime. There's the old pre-prime MathCAD analysis. Then we have Creo Simulate. And the last type here is relation. And the name of this, let's rename this to call it fluid. And then I'll click on the next button. And now we're going to write our relation. And I'm going to use that same name VOL so that it will appear in my model tree. And this volume, this is going to be equal to, and I'm going to use this icon to insert the parameter name from a list. I'm going to change the look-in drop-down list from part to feature, and now I can select the pre-feature in the model tree, and now I then use insert selected. And so now it says the volume is going to be equal to VOL, the name of the parameter, colon, FID underscore 3266. So FID stands for feature identification number. If you take a look at the pre-feature in the model tree, well, its feature ID is 3266. So that's the format. And so now we're going to do, this can be minus, and you don't have to insert the parameter from a list. I'll show you the other way that you can do it. Let's do VOL colon FID underscore, and instead of using the feature ID number, you can use the name of the feature. So I call the second feature post, so I will type that in manually. Let's use the verify relations. Hey, relations have been successfully verified. Great. I'll click the OK button and then OK out of here, and then the check mark to complete the feature. And so now we know the volume at different heights for this plane. And we can actually see how this varies throughout the length of the part. And I'm going to do a quick measurement just to see how long I want to measure. Let's do the distance from the bottom here to the very tip top of the fuel tank, and we can see that that is 439.6. Let's round up. Let's just use a number of 440. So I'm going to close out of here. Then we can do a sensitivity analysis, and for the variable dimension, let me use the pick icon and select the datum plane and select the height of the datum plane dimension. And for the variable range, I'm going to go from a value of 0 to that 440. And for the parameters to plot, here are the different volumes, the one before the shell feature, the one after the shell feature, and here is the actual relation calculation. Let's click the OK button. And the number of steps right now, it's very low, it's only 10. Let's keep on cranking up. I'm going to go up to, let's do 100 steps in between there. And now when I click on the compute button, it's going to be performing those 100 calculations. Let's give it a moment in order to generate our plot. And now it's finished. You can see that it is fairly linear throughout most of it. So they've designed it so that as the height changes, well, the amount of liquid based on the angle of the sides and the other different cutouts, hey, it's going to end up being fairly straight. But then as we get towards the top where we have the cap, you can see how it levels off. And so that's how we can use a sensitivity plot or sensitivity analysis in order to see how the volume changes as a function of the height of the plot. So now we can close out of there, Hey, if we want to, we can save this. Let me rename it. I'm going to call this the fluid height for the name of the analysis, and hit the save button. So that's just so I can retrieve this later on without having to set it up and close out of there. So that's how you can use BMX in order to create a datum analysis feature that uses a relation. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.